That way maybe it won't turn off. Okay. So the force naming system, and here it goes. We're talking about, it is describe the force. If it's a force, it's going to be the label F. So the first thing we're going to call, okay, it's the quantity of vectors. We're actually going to call this the vector naming system. Sorry, everybody. It's going to be the vector naming system. The big letter is the quantity. The little letter, which is the subscript, is where the force comes from, the source, or the source of whatever it is that we're looking at, the source of the quantity. So, for instance, we labeled this a V, meaning it's a velocity of the top velocity of the car, the top velocity of the truck. This is the force due to gravity, So we're going to call these our F sub E, because it's the force of electricity, but then we got to be more specific. The numbers, there's numbers under here, and it actually goes like this. It goes 1, 2 over here. And over here it's going to be 2, 1. That's the right answer. That's how we label these vectors completely. What does the first number mean?
It's kind of hard to see the screen.
Can everybody see? Guy, can you see? Nick?
I'll use the bottom part. The electrical force? Anything you written under source.
The second number equals what? What's the first number?
The object itself.
The object itself, the one that's being acted upon. So, what is being acted upon? And then the second one is what?
By what?
It is exactly by what? So then the way you can read this is the electrostatic force. This vector is the electrostatic force on 1 from 2. Over here, it's on 2 from 1. That's just going to help you get more clear, because we're about to add in a bunch more forces. And you're going to have to be able to label these and understand this little arrow, which is right next to this little arrow. I have to be able to figure out which one I'm talking about here. Okay, so we got the vectors down. Okay. Now we got to get into a vector addition. Give me a hand raise if you've done vector addition in any of your math classes. Give me a hand raise if you've ever seen a vector in a math class. Give me a hand raise if you've ever heard of vector before. So this is relatively new to most of you. Wow, I hadn't realized that. I'm glad we're going through it at the speed we are. Okay, so vector addition. Boom, boom. Here's our status. So here we go. Bring the tail of vector, we'll call it A, to the head of vector B. And I'm just going to draw some random vectors here. There we go. Look at this. Working out, working out, working out. And I'm just going to use my straight edge. I'm going to draw a couple of vectors. What do we want these to represent? Give me some examples. Anything at all. Anything at all. It is the force of gravity. What's the force of something? Force of something. How about the force of Dylan pushing on something? Okay, this is the force of Dylan. We're going to say it's right here. This is the F of Dylan. O-N, Dylan?
Yes.
O-N, the force of Dylan. It's got a magnitude and it's got a direction. Where's somebody else? What's somebody else? Tavish, are you bigger than Dylan or smaller than Dylan?
Much bigger.
He's taller than Dylan.
You're bigger? Okay. So I am going to, let's say that,
Me?
Yeah.
Tavish, how much you weigh?
165.
Oh, he's got 10 pounds on you. He's got 10 pounds on you. But let's assume Tavish is, let's say he's got 110 pounds on Dylan. So is he going to push harder or softer? We're going to say significantly because it helps demonstrate what's going to happen here. I'm going to say this, and I'm going to put it in the same line just to help make the system easy. I'm going to put it in one dimension, so to speak. This is going to be, and we'll say they're pushing against each other. This is my force of Tavish. And notice Tavish has a length of about 6.5. And this has a length of 5.5. So what's going to happen? What happens here? I have got Dylan pushing as hard as he can. I've got Tavish pushing as hard as he can. Tavish is bigger. So what happens? One more time? You're going to go backwards slowly. Because if you were pushing on, say, just this speaker, which produces very little, it's really going to go quickly. But Dylan's pushing back equally. But how slowly? How slowly?
1 centimeter.
1 centimeter, because now we know the magnitude represents the value. So without using any real numbers, I could do this without any numbers. I could give you an estimation of how much difference it would be, because I could say, oh, we're right here, and I could take this and say, oh, he's pushing this much harder, so then my resultant vector is going to be of this length right here, and I'm going to put it parallel just so that we can see. Actually, I'm going to put I'll put it right here. So there we go. Without using any numbers, I'm going to say this is my resultant.
But it's going the wrong way.
Oh, shoot. You're absolutely right. But that means you're getting it. But how did I know which way? Because I did my addition, which is this. Bring the tail of vector A, we'll call that Tavish, to the head of vector B. So the tail goes over here, and then they basically divide to cancel each other out. They're going to cancel each other out. Give me a head rise if you understand. Give me a head nod if you understand what I'm talking about when I say they cancel each other out.
Isn't that more subtraction than addition?
It's both, but you can think of it. That's a really good observation. We're going to add it, but let's just go ahead and define a dimension. That's actually our next word here. The dimension.
Yeah, that's like adding a negative.
Dimension here. This is going to be the way we communicate position along a line. So Guy put up a really, really good observation. He says, well, wasn't that subtraction? Well, if I define my dimensions, and let's just go ahead and say that I'm going to draw a line that's parallel to both of these, because I've put it all in one line, or one dimension. And we'll say this is the dimension. I'm going to go ahead, what should we call this dimension? Any ideas? We could call it anything we wanted to. We could call it Vartunas, we could call it Guy Hayward, we could call it anything we wanted to. But because we're scientists and we're mathematicians, we always get addicted to calling this x. It's our x dimension. It's the x dimension. I don't know why we do that, but does it feel familiar to you? You hear the x dimension in math class all the time? It could very easily be the Vartunas. It could be anything we wanted it to be, but we call it x. So what else do we have to do with this dimension? Well, I'm going to tell you. We got to define the positive direction. So this is positive. So then Tavish, you're actually pushing in the negative direction. So then when we add them, we're adding a positive and a negative together. We define it. I can do anything I wanted to. I could, if I wanted to, define it the other way, and it would still say that our resultant vector is still it would be negative. If you define it the other way, the resultant vector would be positive. But it's still going to give us the same information. You're going to be going that way kind of slowly, because Dylan's fighting like an animal, you're fighting like an animal, but you're a little stronger than he is. Like a beast. Okay, how are we doing on the notes? I'm going to do a quick slip around, and it looks like everybody's keeping up. Good. Awesome. Okay, so that's dimension, and we figured out how to add our vectors in one dimension. Here is where things get fancy. What happens if all of a sudden, let's say Mr. Wanna Sell Ya, you're a big guy, you come in and you hit them both going this way. Boom, just like that. They're both walking kind of slowly backwards because they're both fighting like animals, and then Mr. Wanna Sell Ya comes up and blasts them from the side. What's going to happen? Are they going to go straight backwards with Mr. Wanna Sell Ya?
Back it in.
I mean, it's going to be pretty much that. I mean, how much?
How much he's pushing?
Look at this. This is such a good representation. Here's Dylan. Here's Tavish. They're going to subtract, and we have a slow motion going this way. All of a sudden, Mr. Wanna Sell Ya, let's say he's Big Blue here. He's Big Blue. He's big. Mr. Taylor, you want to help me out with this? Well, you said it. Wow. Big Blue over here. About the same size. So, same magnitude here. So, what's going to happen when he hits him here? Boom. Okay, he hits hard, he hits here. Is this what's happening?
It's going to go at an angle.
I don't know what that means. What do you mean it's going at an angle? More specific.
They're going to break apart.